kind of hard to find.
What?
Why is that? Why is it hard to find?
It's not as easy as
Because it's not. Yeah,
it's not easy, but a little hard work is worth it.
That's what hard to find means. I didn't say it's impossible. It's not
No,
like the North Star.
I think the southern celestial pole is more difficult because you have to kind of figure out where it is and about a center spot about these other stars that you do know where they are, that are easy to see.
That's the point I was making, I think.
Yeah. Okay. But why is the fact that the celestial bodies all move opposite directions in the south versus north? Why do you think that is, Essie?
I think you're late to the party. Is Moyak here?
No, I was asking you. I am late. I just got here. Okay, all right. Writing an A shows he's been here since last night. He's been here the whole time.
We already went through this, bro. I don't want to go through it again.
Just high level. Just like the Cliff Notes, just like a one sentence.
Well, we talked all about the stuff that you want to get into right now.
No, I don't want to get into anything.
And I asked them, okay, fine. This is what I want you guys to do. Make a model of it, recreate it. Get a medicine ball, put a little camera on it, easily done with a phone, let's say, or whatever. Spin it, have lights in the ceiling, like recreate the lights in the sky, and show me 3 different motions. One linear, and one on either side of it, a counterclockwise and a clockwise motion.
I can actually do that. That'd be kind of, I have a small GoPro camera I'll stick on there, tape it to the side, and we'll spin it around. And I have lights I can put all over the place. And what you'll see is exactly what you think you see. Things at the equator will go in a straight line. Things on the North Pole will rotate counterclockwise. And on the Southern Pole, they'll go clockwise. I'm asking you, why do you think that is? Why do you think that is that we see that in like Australia versus like North America or Europe? Why do they go different directions? And I don't need to get into it. I'm just curious your opinion, Jesse.
You mean why do they appear to go? First of all, I want to see you do this. Are you going to be a man of your word and you're going to make this model?
Sure, I'll do it. Yeah.
Okay. All right.
So tell me, but in exchange, why do you think this is observed in appearances? What you see, sometimes what you see is caused by other things. But why do you think it is that we see that?
First of all, I haven't seen that myself.
You haven't looked out your window and seen things go. You haven't looked out your window and seen things go counterclockwise.
No, I've seen things go counterclockwise and clockwise, of course. But we're talking about the stars now. If you're at the equator, if you look up, you should see a linear motion, a counterclock motion to the left, and a clockwise motion to the right. Correct?
Yeah, I think we have video. We've shown video of that here.
Yeah, there's plenty of that going around, but I want to see that recreated. I want somebody to recreate it, show how it's done. Because if the stars move in one direction, right? We see them move in one direction across the sky. Would you agree with that?
No, I don't agree with that at all.
So you're saying the stars move in one direction.
By definition, By definition, a circular path is a constant change of direction. So it's exactly opposite of what you just said.
Okay, let me rephrase that then. When we look up in the sky, how do we see the stars moving?
We see them moving in a counterclockwise rotation in North America, northern hemisphere.
Right, all in the same direction, right? Rising in the east and setting in the west, right?
No, no, they don't, because they take a circular path. But I'm thinking about what you're saying and think same direction. Like, which way does your clock hands move? They all move the same direction. It's clockwise. Is clockwise a direction? Maybe that's where the confusion is.
Okay, let's get to the nitty-gritty. When we look at the stars, they move in a clockwise fashion. Yes or no? When we
look
in the
southern hemisphere.
And in the northern?
Counterclockwise.
Now, is that an apparent or an actual rotation?
That is an actual rotation.
So the stars are actually rotating counterclockwise in the south and actually rotating clockwise in the north.
Define actual.
Define actual?
Yeah. Like, for
You're
example, when
kidding.
we talked about Coriolis and things, is the ball actually moving straight or is it actually curving? I'd say yes for both of those. But it depends on your definition
No,
of
it's
actual.
not.
Oh, no,
You're
it is.
listening, Jeremy?
Remember, words have meanings, and definitions
there's
are
really
critical
no
here.
point in it.
No,
You see why I
Jeremy
don't want to get
Jeremy can
into it
back me
with
up
these
on
guys?
this.
Because they're in La La Land.
No, you heard what I said? So actually can be both. It's reference frame dependent, is it not? I mean, if I'm in a Coriolis analysis, they're both real. They both have effects. It depends on how you're looking at it or where you're looking at it from, which reference frame you're looking at it from. So if you're looking at it from a rotating reference frame, it is actually turning because you can plot out the coordinate systems and see the path is actually a curved path. I can give you the coordinates and it is a curved path. So actually it is. But when it actually means absolutely or in an inertial sense, then you'd be right. The only actual movement would be the straight line, and that'd be only viewed from the inertial reference frame.
Did anybody understand that? Is he saying two things at the same time, or is it just me?
Now, Jeremy knows what I'm saying.
So what are the stars? Are the stars actually moving
Can you define actual?
clockwise?
Can you define actual, please?
Yeah, actual for real. In other words,
No, that's not good enough.
that's
Like
not
when we
good.
throw a
Okay, can you
ball in
define
straight-
actual?
Well, hold
I
on.
just told
Like
you.
when we throw a ball, hold on, Zanick. Like when we throw a ball in a straight line on Earth, we know how to actually throw a ball in a straight line, right?
Right.
Right. We know how to actually, so we know the ball's actually going straight.
How do you know it's actually going straight?
Because do we know how to actually throw a ball in a straight line on Earth?
You're saying two different things: how to do it and what you see. What are you talking about?
Yeah. Do we know how to actually throw a ball in a straight line?
How do we? I'm confused what you're asking because no, you
Can
don't.
do we know as humans how to actually throw a ball in an actual straight line
Yes,
on the
we do.
actual Earth we stand
And we
on?
know how to shoot. And we know how to shoot a shell in a straight
Okay,
line.
so we can
over 25
actually
miles.
hold
Do we
on.
know how to do that?
Let's baby steps.
We don't know how to
So
do
we
that.
can actually.
We can't do that. It's not possible. It's not possible to
hold
throw
on.
something in a straight line from a gunboat to the northern to a northern shore of England from the ocean in the south. We don't actually know how to do that. We can't do it. It doesn't happen.
You can't get nowhere, Essie. There's this.
Well, no, I'm just telling you.
That's why I told you, Jeremy. That's why I told you. I tried to pass the baton to you, so you.
Confusing,
This guy
Jeremy.
forget it.
Don't pass this shit off to me.
Jeremy, you know this. And you're walking it back. You know, you're doing the same thing. You're doing the same thing to me that I did to you, right? Now you're pussing out, looking at your peers here. You're backing down. Look at you. You're cowarding away. Jeremy, you know
I'm
this.
on SE's side.
I know you
side.
are.
I think
That's why you're a traitor.
Actually,
you're a traitor. You totally walked it back. You were a strong man, big man on campus. You knew Coriolis. You understood reference frames, and now suddenly you regress back to an infant.
Listen,
You mean you saw the light?
Unlike
You saw the light. That's what you want to say there.
No, he's gone backward. He started out not knowing it. Spent a year studying it. Now he knows it. Now he's walking it back because you're there. Because your deep, very convincing voice, SC, an intelligent voice, is crushing him. He's bowing to you now. He's paying homage to your greatness.
But it doesn't work on you.
I'm never going to get
work on you
because I'm like a robot.
Zanick, can I ever have a chance to respond?
Yeah, I just spew truth. You see, I'm like a robot. I don't bow.
Let Jeremy say his piece, bro.
He's not. He won't let me. He can't let me.
Of course I will. You go ahead.
Oh, okay. So unlike you, I think that we actually know how to throw a ball in an actual straight line on Earth. I don't know what your contention with that is. It's weird if you have a contention with that.
Straight line with respect to what? The shortest distance between 2 points? The shortest distance between 2 points, is that a straight line? Jeremy, I'm going to play with you here. You're going to lose, by the way, once we go down this path.
Oh, you're going to pull a Bob on us now, Zanick?
Well, I mean, Bob understands it too, but I have a little different way of explaining it.
Please, go ahead. The popcorn is out. Go ahead.
Okay. Jeremy, is a straight line the shortest distance between 2 points?
Jeremy, indulge him. Say yes.
He won't play my game. He knows all.
Trying to negotiate with a 4-year-old. I'll be right back.
No problem.
Hey, I know.
I know, Jeremy. I know. Let's see, where I'm going with that is actual, means what you see. I mean, you actually see something. And you're thinking absolutely. Does it absolutely go straight in all reference frames?
Zanick, you can't back out on it from now.
I'm
You
not
said
backing out.
that
I'm giving
both.
you so much rope. You either can flourish with it or you're going to hang yourself with it. Yeah, see, which is it?
Bro, you already drowned. You already hang yourself. How many
No,
times?
not me. See, you can't project onto me. I'm telling you, I'm giving you the rope. Now, divine actual, is it what you see or what it is?
You said that a ball actually travels both straight in one reference frame and actually curves in the other one. Now, how can you recover from that?
Perfect.
You can
Perfect.
never recover from that.
Perfect. If you stop there, you have my respect, and you and Jeremy are on the same page because Jeremy knows this, by the way. And we can stop there because yes, they both are true. It's not double
What?
speak. They both are true.
So you're tripling down on it again. This is the
Of
third
course,
time you're going to say it.
SE. It's something that I understand completely.
You might understand it. You might
No, I'm
accept it.
understanding. I understand it, know it, have knowledge of it, and are able to convey it to you. You are putting barriers up. You don't want to entertain the idea that something can actually curve and go straight and
At the
both
same
be
time.
At
true
the same
at
time.
the
At the
Yeah,
same
same
finish that
time.
at the
sentence.
same
Finish that
exact
sentence.
yes, at the same exact time, because how you're looking at it makes all the difference in the world.
You
No
heard it,
pun
guys.
intended.
You heard it.
If
Zanick,
there,
have you heard of the term
Uh,
dialetheism?
no, I have not.
Okay. Dialetheism means the acceptance of two truths. You have
Mm-hmm.
two truths.
Well, this would be one of those then, if that's the definition.
Absolutely. This would fall in that category. Yes, sir.
Okay. And now I need to say it one more time because I think you might have missed it, even though I said it 10 times earlier, that in the reference frame you're looking at that motion from. It will make a curved path or a straight path simultaneously because both will be happening. Can an inertial reference frame contain a non-inertial reference frame? Of course. It's a subframe. It's a local reference frame. Do you know what a local reference frame is, first of all? Yes, see. Have you heard the definition of a local reference frame?
A local reference frame
Yes.
as opposed to a far away reference frame?
No. Local as opposed. See, so I'm going to teach you something. You taught me a word I didn't know. Dilithium crystals. What
No,
was the
no,
word?
no. Not dilithium crystals.
I know. I'm just kidding. I'm kidding.
Dialetheism.
Yeah, I know. Dilithium. It sounds like dilithium crystals. That's how I'm going to remember the word. I never heard that word before. So you taught me something. Now I'm going to teach you something. So a local reference frame, which you don't know what it is, and an absolute reference frame. A local reference frame can be within a absolute reference frame. You get me so far.
Well, give us an example of this, please.
Well, we could have a reference frame that is rotating, and we can have a reference frame that is not rotating. Both are point coordinate systems, and the local reference frame lies within the absolute reference frame, and there's math to actually do transforms between them. So you can actually analyze the motion within either one of them from the perspective of either one of them. Does that make
So a
sense?
reference frame within a reference frame? Is this what you're
Yes.
trying to say?
Yes.
And how does this apply on the ball and the merry-go-round, please?
Well, if you're looking at something from the absolute reference frame, it'll appear different than when you're looking at something from the absolute reference frame.
You just said absolute
Oh,
twice.
I'm going to say, well, I'll look at the TV real quick. If you look at something from the absolute reference frame, it'll look different than looking at something from the local reference frame. And you can
Okay.
you can predict what that path of that object moving in it will do, depending on if it has an inertial state or not.
So
There's
what?
also objects that are moving in it that could be inertial or non-inertial themselves, which makes it even more complicated. And we use transforms. There's math we use to actually determine the path and predictions of motion in those environments. based on what reference frame you're looking at the objects from.
So
Does that make sense?
what? Does that change the motion of the ball traveling in a linear path?
Well, yes, depending on which reference frame you're looking at it from, yes, absolutely. For example, if you're looking at that ball that was thrown in the inertial reference frame that went straight, and now you're in the rotating reference frame, and you're looking at that ball being thrown that it has an inertial state once it leaves that person's hands, it will make a curved path in your reference frame. In the rotating reference frame, it actually curves. You can plot it. You can predict it.
You keep saying, I can't believe it, man. I just can't believe
I know. This is
how your
mind bending
brain
for you.
works, bro.
I'm spending time because I know it's mind bending. It's not simple. It's an abstract thought, but you're fighting it, and you know it's true because you know if you go on a merry-go-round and I throw a ball across the merry-go-round, you know that it looks like it curves.
Looks. Now you said it correctly.
Fair.
Now you're changing the story.
No, it actually curves. In the reference frame, it actually curves. It will curve. You throw the ball, it curves to your buddy. He's over to the right. You throw to the left. It takes a curved path to the right. It actually curved. It truly, actually, positively, absolutely curved.
Wow, I don't know what else to say to you, bro. You're truly a dialetheism in action, like live, real.
If that's the
What do they
definition,
call it?
yes.
VR?
There are two truths there. You don't think that when you throw the ball across the merry-go-round that it takes a curved path?
I'm with you.
Well, you're breaking up real bad. Oblivion, you're breaking up really bad.
Really?
Oblivion,
Oh.
you had a real problem with your connection, whatever it is.
What's up, Zanick?
What's up, Bubba?
What's going on? Yeah,
How
Jeremy.
you doing, man?
Not much, man.
Let
SE
Oblivion say his thing, bro. Hold on a second. Kosho.
SE and I were talking about dialetheism.
I was saying, I'm with you, Zanick, right up until you said the ball actually really did curve, when we know it didn't. But I know what you're saying, but it appeared to.
If you didn't know if you didn't have any other exposure to any other environment, you're on this merry-go-round permanently. It's a big merry-go-round, and it's always spinning, huge merry-go-round, like the Earth, but it's moving really fast. So everything you do makes these weird, from our perspective, from people like us.
I get it.
But you would never know. All you know is when you throw a ball, you better, if you're throwing it north, you better expect this thing to turn right. If you're throwing it south, you better expect this ball to turn right. And it's always turning right, no matter where you are. And that's your reality. It's actually turning right because everything you do in your life will be based around this ball turning right whenever you throw it. Everything.
I get it. So, like, for instance, if I went outside at night and I was smoking a cigarette and looked up at the sky and I saw this light streak across the sky, but it curved at a radius, I would go in and tell my wife, "Holy shit! I just saw this streak in a curve." So I get what you're saying.
Everything would be curved, right? Unless you're able to force things to go. Now, here's the mind bending part, SE. And I'm glad you brought that up, Oblivion. Now, say you saw something go straight. Now you have a whole new set. We'd have a whole your culture, your environment. Everybody would know all these laws of physics, and you draw some math about it too. People would figure all this stuff out. So if you ever saw something go straight, you go, "Fuck, that's impossible. Nothing can go straight in our world," right? Because you have all the math to prove it. Everything you do curves. So that must be a spaceship with forces to make it go straight. So that required a force in your. So it'd be a pseudo force. It'd be a pseudo force in respect to your in your environment. So nothing can go straight in your environment. You don't know of any other environment. All you know is where you live and you're spinning, and everything you throw curves, actually curves, because that's the environment you're in. How does that make more sense to you, SE? If you looked at it from like where you live, your environment perspective.
Zanick, I don't know what to tell you, bro. You keep cracking me up.
No, if you didn't know any,
I think we live in different worlds, bro.
If you knew nothing else, but your world was spinning, if you knew nothing else, and everything you did made these curved paths, how would you know there was anything? What inertial even means? Inertial would be the opposite. If anything was going in a straight line, you'd say, "Well, that required a force to do that," and that would be true. because it's all see, this is it's an abstract thought. I get, Essie. You're not familiar with it. You haven't studied it. You haven't used it in your day-to-day life. Most people have not. Even I have not. But it is a truism. It is an absolute fact that if you are looking at something that is rotating, that is an accelerating reference frame, you will observe actual movement that is a curved path for objects that otherwise would be straight from an inertial perspective.
Observe. Now you're changing it again. You mean actual curve.
Actual.
Yeah, that's
it's actually curving. Because actually means what actually means, did it go from B1 to C2 to D3 to E4? Is that the path it took? And you'll say, did it actually do that? SC, I'd say yes, because I can plot it. I know where I took a video. I have a point coordinate system superimposed like a matrix. You can see all these dots everywhere. Every dot is equally distant from every other dot. It's a matrix, right? And I can plot very accurately the path of this object. And every time I throw it, every time it's shot, it follows this curved path. It actually is doing it. So yes, actually and observed are one and the same in that reference frame.
Sheer delusion, bro. Sheer delusion. That's all I
can.
There's only one way to say that.
You know what's funny is here you are, not knowing much about it, but very articulate and very intelligent, as you are, I can tell. But every physicist in the world would agree with me. Every single one. There's not one that wouldn't. Isn't it millions of physicists that have studied this for 8 years of school, PhD physicists, they all would agree with me. Every single one of them, except for you. Isn't it kind of a Dunning-Kruger thing?
I challenge any one of them to a debate on this. Any one of them.
Convince him.
You?
Yeah,
you?
Me.
Why are you? Why do you feel you're delusional? You called me delusional. I have to call you delusional. Why do you think you're equipped to make this argument? You can't even make it with me. And I'm not a PhD physicist.
Just tell him this delusional, crazy dude wants to debate you on this.
Hey, Zanick,
I say they more than happily will do that, especially the ones that are a little bit, eccentric like me. They'll do this for the fun of it, because they will be like, how are humans in this planet being so dense? And that word dense does not mean the molecular distances. We're talking about dense as in your brain. You're not opening it up a little bit to understand some basic concepts of physics. We're trying to help you, and you're just resisting it with all your might, all your tenacity.
Let me tell you how I see it from my point of view. This is what's happened to you.
Why do we care with your point of view?
You've been listening. Well, why are you talking to me then?
I'm just kidding. Just kidding. Go ahead. Go ahead. What were you saying?
This is what's happened. You've been listening to the shadow giants, right? Particular Einstein. You've been told a story. You bought the story. Now you're repeating the story. What we're doing is showing you the nonsense of this, and you're clinging on to these shadow giants. That's what's happening. You're in a state of confusion and denial.
Zach, can I offer you something? Because I don't want to take away conversation with SC, but I thought maybe because I heard I get where you were trying to go with the that whole other universe, or like your observation being made from that rotating frame. You were arguing that there's not an actual frame, and then the one where it appears to be doing something else in some other frames. Like it's at whatever frame it's being described from is what it's actually doing. And I was going to offer you that the Galileo's, what's it called? The Principle of Relativity, which is how he describes all motion as being relative, and you can't even describe motion or speed or velocity, acceleration, anything. You can't describe any of it without some reference frame. And so, just because you're in one reference frame and not another doesn't mean that if there's some true sense to what's happening, right? Like there's not an actual event. There's not an actual path. There's actual paths in every reference frame. So
that's ridiculous. That's relativism. That's a pile of nonsense. You have to believe in what you said right there. You have to believe that a ball could both be traveling straight and curving at the same time.
Right. That's actually what
I say to you, physics does not allow that.
That's what I was about
physics
to say
does,
to you.
actually.
I was about to say that's just the last thing I was going to say to you. I was going to ask you to describe to me the path of a ball. It should be very easy. Not any single path, but the actual path of the ball. And this ball is being thrown by a dude on a scooter on a cruise ship, going like, I don't know, whatever speed you want it to go. Okay.
Or you're going to start with the cruise ship again.
And it's being observed by many people on the shore, people on the cruise ship, other people on scooters on the cruise ship. And so just describe to me how fast the ball's going, path of the ball and all this kind of stuff.
I'm going to describe to you just pick a speed. Pick a speed. When a person throws a ball, how fast do you think? 20 miles an hour, 30. It doesn't matter. The speed.
The boat's going 10 miles per hour. The scooter's going 10 miles per hour. And the river is also flowing 10 miles per hour. Okay. And the ball is thrown at what speed?
Pick a speed, 20 miles an hour, let's say.
Maybe there's a better way to phrase that question by asking like, if you try to measure how fast the ball is moving using like a radar gun, where would you put the radar gun?
This is not about speed. This is about the appearance of a ball traveling. When you throw it in a straight line, how does it appear on a rotating frame of reference as opposed to the non-rotating frame of reference? That's what this is about.
I know, but this is the fundamental disconnect. This is why we're talking past each other. It's because we're not talking about the same thing, and that's why I'm bringing it to the most simple way of describing it. Like when you said, "Oh, that's just relativism," I'm trying to show you that that's the way all motion is described. Any motion.
I think. Can I put a quick? Yeah, Kosho's done a great job of trying to set the stage for it. And SC, I'll just cut to the chase because I know you don't like and don't have the patience for a lot of this. In talking about throwing the ball on the boat on the river, going at some speed, where do you get the radar gun? Where do you put the radar gun? If you put the radar gun on the island, if you put the radar gun on the boat, you know you'll get a different speed for that ball, right? Which one is correct?
Who's talking about speed? Why are you changing this to speed?
We're just talking about relativities.
But you're talking about speed. I'm not talking about speed. It's irregardless. I'll give you any speed you want. You want 20? You want 30 miles an hour? You want 33? Maybe your favorite number. No problem.
It's not about the speed, but where to put the radar gun.
I'll let you go. Let him go. So we can't fight the flow here. Let's see. Let him roll. Okay, so any speed. So 33, my favorite. Actually, is my favorite number. My football number. I like that number.
You see, I told you.
Yeah, good guess. Okay, so we got 33. Wow, that's kind of spooky. You know that. All right. Anyway, so 33 miles per hour. And we measure it from where? Are we measuring it on the ship when he throws the ball with the radar gun? Or are we measuring it from the island across? We're approaching this island, and I measure it with a radar gun. Where do we measure it from?
What are you guys going to bring in that next? Hula hoop and dancing girls. Dude,
no. Just stay focused.
In a straight line.
This is a quick one because I know you know the answer, and I'm just going to draw the analogy, and you're going to say, "Oh, that's bullshit." But that's okay. Let's just go through the exercise real quick. Those are great points. Kosho and Bacon both brought it up. So you got a radar gun, and you're on an island, and you measure this ball on the boat across the. You can see the boat. He's approaching you. He's almost going to run into the island, and someone throws the ball on the boat, and you measure 33 miles per hour. Now, if you put the radar gun on the boat, would you measure 33 miles an hour?
What does that have to do with anything?
Well, I just play.
What do you think? What do you think?
Me. Well, we know that
I'm not playing your games, bro. We're talking about motion.
I'm just trying to get your mind wrapping around.
No, you can talk about
relative motion. I'm just trying to get you to understand relative. I just posted a.
You can talk about fairy tales all you want. Radar guns.
It's not. Can you let me?
The ball is traveling in a straight line.
Okay, no, I'm just trying to get you to understand relative motion. Just real. Let me. Okay, you know what? Don't say anything. Let me finish my sentence. Then you can make your comment. So we have a ball that we've now measured from the island that says going 33 miles an hour, but when we went on the boat, it's only going 13 miles an hour. You understand? Now they're both actual. It just depends on what point of reference you use. Now in the relative motion in curve paths or reference frames, which is different than relative motion from points, you will see the same analogy that if I watch that motion from the rotating reference frame, things occur in the point coordinate system that I can plot and predict. And if I look at that same motion from an inertial reference frame, I will look at that motion. It'll be straight. It'll be inertial. And I can plot it as well, which is correct.
So are you
Both are
saying,
correct.
okay, you're talking a lot, bro. Take a break.
No,
So
I
are you saying
had to
because
describe
you
two
measure
scenarios.
different relative motions, are you saying that that relative motion is caused the ball to actually curve instead of going straight? Is that what you're
Yes.
saying?
Depending on the reference frame, it will either
Oh
actually
my
be
God,
curving.
man.
Okay,
I can't
okay,
do this anymore.
Well, hold on. You say you're so smart, and maybe this is a poor product of me and the institutionalization I've had with all the people telling me what I should think. You could be right there, but I posted that blurb about the changing the frame of reference, motion, physics. This is in the physics books. You talk about defying laws of physics. I'm showing that it mentions transforms. I also mentioned that too. This talks about the local frame and the absolute frame. There's a transform between those two, by the way. This is exactly speaking to what I've been trying to tell you about. It depends on where you view the motion from. If you view it from a
Yes, when you
rotating frame,
talk
it
about
curves. If you view it from an inertial frame, it doesn't curve. They both are true. They both are correct. I don't
no,
know how more simple
incorrect,
to make it.
absolutely wrong. When you say appear, yes, but when you say they really do curve, you're wrong. And there's nothing ever that you're going to say, no amount of math, no amount of reference frames that you bring up that are going to change that, Zanick. Understand
Okay.
that.
So, in other words, you can't think in different reference frame. Go back to the very first sentence I started with. I want to know the definition for you of actual, what actual meant to you. And now you've defined it. Actually means to you inertial. So everything you see is from an inertial perspective. And I get that. You can't get out of that inertial frame. It's a common mistake that most people in physics make when they first start learning it. And you're making it. And it's okay. It's not bad. A lot of people do this.
No.
No,
You're
it is.
making the
It's okay.
mistake.
No, I'm not. No, don't
You're
attack
fantasizing.
me. You can attack me later. I'm attacking you now because you can't look at things from a different frame of reference, and that's fine. So your definition of actual, and we all can have our own definitions in context. Your definition of actual means inertial, and that's all I'm going to say. And I'm not going to
I'm
change your
in the
mind.
real world. You're in fantasy.
Real word. What is define real? What does
I-
real mean? What does real mean?
What is real? What does real mean? Real
Yeah.
is this. When you throw a ball straight, it goes straight. It doesn't curve.
Really, on the merry-go-round, the
That's
ball
real.
curves.
Yep.
The merry-go-round ball curves. You throw it to your buddy, it curves to the right if it's spinning counterclockwise.
It appears.
No,
The ball is actually traveling straight at your buddy, turning into that.
He catches it from a curve. He even turns his mitt to the side because the incoming trajectory of that ball is curved, and it comes into it at an angle. So he has to get his mitt to the side. So he actually catches it from the side. How could it go straight?
Because he's curving, not the ball. He is the one curving, correct?
Correct.
He is in the non-inertial reference frame, correct?
Also, he has a reference frame,
They
right?
all are. Everybody's in the non-inertial reference frame because that's how we're looking at it from.
If he has a reference frame, if he has a reference frame, and you use that reference frame, there would be a curve in that reference frame. You agree that he has a reference frame?
It would appear. It would appear
No,
to
I'm
curve.
saying in that reference frame, not actually, but in that reference frame, right? Because you agree that he has a reference frame that is actually rotating. So if you use that reference frame has a curved path.
No, I'm not saying that's incorrect. It appears to have a curved path.
I'm not saying if it appears or if it actually. I'm not comparing appears to actually. I'm being very specific. I'm referring to the path in that reference frame.
Yes, and I'm being equally as specific. The ball is actually traveling straight always, and in the rotating reference frame, it appears to be curving.
Yeah,
nothing
it appears to be curving because in that reference frame it's curving.
Okay. Right? Remember, Bacon, I'd be there when Brett mentioned if we lived in a world that was spinning really fast, really small, and that we never knew anything else, and everything we did made these curves path. How would you know that things are going straight, actually, in your world, SC? If everything you saw curved, you threw a ball, you walked, you were always leaning one way, everything you did was, and we had a whole set of physics that had this equation, 2 omega times VR equals this force that is always with everybody on our planet, on our plane, or whatever you want to say you're living on. It's all there, and we never knew anything else. because all we saw was this. We didn't have any reference points above us, no stars over our head. All we had was when we throw a ball, it takes a curved path. How would you know that there's any other reality of that? How would you know? Yeah, see,
What kind of question is that?
What kind of person?
What kind of question is that? If you were to throw a ball and it would take a curved path, we would not be in our physical world. We'd be in another realm.
Well, yeah, no, you could be.
That is a nonsensical question.
If I put you in a huge room, like the size of the biggest building on the planet, where it's like a mile across in every direction, and you are, and that whole entire building is spinning, and you have no idea of anything else. You never left out of that building. You're not. It's like almost like what was that movie with what's his name where he's like it's a simulation. Anyway, you're this building spinning. You never have left the building. You don't know there's anything outside the building. It's your whole world. It's so big, you have no reason to suspect anything else. You're born there. You were brought up there. You played baseball there. You played football there. You've run there. You've driven cars there. Everything curves to the right. Everything, matter what you would accept that as your reality. How would you know that there is something where you can throw something straight? Because your reality would never allow you to see something go straight. How would you know that there is something, the reality where the actual reality where something could go straight? How would you know that?
What kind of nonsensical stuff are you? You're starting to make my brain.
No, I'm just trying to say, if your knowledge, if you didn't know, if you didn't know
I'm not the only one. This guy is hurting my brain, Jeremy.
Bacon, do you understand what I'm saying?
Yeah, but I don't think that's gonna help it.
Why? Because if he didn't know, how would he know? If he didn't know of any other situation where a ball can go straight, he never seen a ball go straight ever in his life. It's not possible for him to throw a ball. The only way you can make something go straight is if you add forces to it, which is the inverse of 2 omega times VR.
I prefer the boat analogy. You can ask, how fast is the ball actually going? There's a difference.
I know that was he didn't like that because it's not rotating. It's not rotating, so we had to go back to rotation.
There was a claim that is very easy to demonstrate, which is that the ball is curving in the frame of reference of the rotating in a rotating frame of reference. Because what is a frame of reference? It's just the coordinate system, right? So if you have this coordinate system rotating, every second the ball is in a different position on that coordinate system. So you can draw a grid on the merry-go-round and plot what's the position of the ball in every second or every tenth of a second, and that is going to form a curve in that grid. We all should agree with that. That's sort of obvious, right? So if it forms a curve on the grid, that is the exact same thing as saying it forms a curve in the frame of reference, because that grid is the frame of reference. So you cannot say that it's not curving on the reference frame. It's going straight actually, but appears to curve. I'm not disagreeing with that. What I was asking you, C. Montreal, is if it's curving in the reference frame. And the answer should be obvious.
Yeah, the answer is obvious. It appears to curve. We're doing this. We're going around in circles over and over and over.
Not the question. The question is what happens to the path of the ball in the reference frame that is rotating. That's a very specific question, and there's only one right answer.
It appears to curve. That's what happens to it. It's very simple. Because if it wasn't here, let me put it to you this way, Bacon. And I gotta go over to next level. We're gonna go live soon. Let me put it to you this way, simple. What if the merry-go-round is not spinning? How does that ball appear in that reference frame?
Straight.
There you go, bro. It's as simple as that. It's as simple as that.
Why?
Wait. What was the question again, SC? If the ball is not spinning, or what's not spinning?
If the merry-go-round is not spinning, and one guy throws the ball from one side to the other, how does the ball appear?
In a rotating reference frame?
No, nothing's rotating, bro. The merry-go-round is not rotating. You have one guy on one side.
Reference frames are not merry-go-rounds are not reference frames.
Oh God!
The reference frame is the point coordinate system that contains the merry-go-round. So you're making
Jeremy, please take over. I can't do this anymore, bro.
Of course you can't. Your brain is not able to handle it. It's not. It doesn't have the capacity to deal with this topic.
Bro,
Nobody's shown
you're
that.
a lame brain. I'm telling you, you can't answer a simple question. A merry-go-round.
That's projection right there.
Zanick, a merry-go-round, not spinning. One guy on one side, one guy on the other. How does the ball appear to move?
Depends on the reference frame.
I'm trying to ask it a different way. So
What different way, man? It's simple question.
I could have a reference frame that I've created a reference frame that actually is rotating. That I'm looking at that stationary.
But
in your
it's
world.
not rotating. I'm specifically telling you, it is not
objects
rotating.
are not reference frames. Objects are not reference frames. They occupy space in a reference frame. And if I have a reference frame, all reference frames. Yeah, you don't understand reference frames. That's okay.
There's nothing more I can tell you guys.
Yeah, I know. You're true. That is absolutely. That's a truism. That's a truism.
So Zanick, I'm gonna go now. We're gonna go live soon. I'm holding you to task. I want to see your model with the medicine ball and the lights you said. Deal?
So I have a globe. I'll put a camera on the globe. I can spin the globe, and I can see these objects and all the reference points you've talked about, and see the relative motion between them.
All right, I'll give you whatever time you want, and
yeah, you'll see the ones on the North Pole. They will go counterclockwise. In the South Pole, they go clockwise, and on the equator, they will all go in a straight. Well, the ones will be that are in line with it will go in a straight line, where the other side will be opposing directions.
Okay, cheers. Let's leave on that happy note. Cheers. Thanks for the convo.
You got it.
Later, guys.